Okay, number 21 off the final exam review. We have a 6 kilogram mass, so this guy right here is 6 kilograms, hung from a spring and stretches the spring 31 centimeters from its initial position. So say that the spring is like, when it's like this, it's just chilling. It's not being stretched, not being compressed. Along comes this 6 kilogram mass, and it stretches the spring 31 centimeters. So like down to here. So here's the mass down there. It's just, stretched now. What do we want to do to the centimeters? Centimeters, got to put it in what? Meters. Like notice the answer here. Notice the answer, guys, up here is in terms of what? Meters. So 31 centimeters is 0.31 meters. Now, how do we figure out the spring constant? How do we figure out the spring constant of the spring? Now look, let me just remind you of what the spring constant is. Every spring has its own spring constant. And basically the spring constant is how strong the spring is. If you have a real tight spring, that has a big spring constant. If you have a loose spring, that has a low spring constant. Well, let's just say for example that this spring constant were 100 Newton per meter. That's the unit for spring constant. What does 100 newtons per meter tell us? If you grab the spring and stretch it 1 meter, how much force will the spring give you? 100 newtons. What if you stretch the spring half a meter? 50 newtons. So look, the equation for force of spring, this is the equation for the force of a spring. You take the spring constant, which is Newton per meter, and then multiply by x. And by the way, x is how far you stretch the spring. In this case here, the x is 0.31. What is x measured in? Meters. So what happens here? Meters cancel, and you just get what? Newton, which is force. Right? So the equation for force of spring is K times x, where K is the spring constant. Okay? Now, how do we solve this problem? How do we find the spring constant? Yo.
Sorry to interrupt. I got to go to the restroom. I got a credential person in there, but I just want to let you know.
Okay. How do we go about finding the spring constant? Step 1, free body diagram. So look, focusing on this mass hanging down here. Focusing on this mass hanging right here. How many forces are on that mass when it's just hanging?
Gravity.
2. We got gravity down. What's the equation for force of gravity? mg. And then what's the upward force?
Tension.
Well, it's not a tension. It's called force of spring, which equals kx, right? So basically, let me just put it here. What we have is when the mass is hanging there, we got force of gravity down, which is mg, and then the upward force is the force of the spring, which is kx. Now, sum the forces. I think you see where this is going. What must be true about these two forces? They're going to be equal, but let's do it the superphysics way. The superphysics way is you'd go, okay, up is plus, down is minus, right? So we have kx up, mg down to make the mg minus, right? Sum of the forces always equals what? ma, but what's the acceleration here? 0. So what we have is kx equals mg, so k is mg over x. So the mass was 6 kilograms, gravity was 9.8, and then x is 0.31. So you punch that into your calculator, and you get 189.7 Newton per meter.